Today we're going to be looking at the 2018 December Gold question, Teamwork. So in this question, Farmer John wants his cows to wrap presents, and so what's going to happen is his cows are each going to have a certain skill level. And so he's going to divide them up into teams of at most K cows, and what we want to do is if a certain amount of cows are in a team, then all of them automatically get promoted to the skill level of the most skilled cow on that team. So what we're going to do is we want to find the highest possible sum of skill levels Farmer John can achieve by grouping the cows together. So let's go look at the algorithm for this question. So the main algorithm we're going to use for this question is going to be DP. And so what we're actually going to do is we're going to have a one-dimensional DP, and our main state, or the dimension value here, is going to be the current cow. So our cows are going to go from 1 to n. And so what we're actually going to do for our transition is pretty simple. We're basically going to notice that what we can do is we can calculate the value of the last group and then just add the cow before it, or the DP value right before it. So if our last group goes from I minus k to I, then what we can actually do is we can add DP I minus k minus 1 plus the group value. And so what we're going to do is we're going to have two for loops in our code. And so our first loop is going to go from 1, or actually 0 to n, and this is going to be I. And then our second for loop is actually going to go from 0 to k. And so what this value is going to do is it's going to store all of the values between 0 to k, and it's going to represent the distance in the last group. When k is 1, it's going to mean the last value is from I minus 1 to I, all the way up until I minus k, because the maximum size of a group is going to be equal to k. And so with this idea, what we're going to do is we're going to loop through, and we're basically going to find the value of this, and we're just going to make dpi the maximum of dpi minus k minus 1 plus the value of the last group. And so what we're actually going to do in order to calculate this value here is we're going to keep a running maximum of the greatest value in the last group. So since k goes from 0 to big K, then we're going to start here. We're going to make mx, or our maximum value, the max of I by itself, and then when k becomes 1, it'll be the max of I minus 1 and I, and then when k becomes 2, I minus 2, and then the old mx, I minus 3, and the old mx, and so on and so forth. And so what this value is basically going to be is it's going to be k plus 1 times mx, because there are going to be k plus 1 elements in the group, and they're each going to have the value of the maximum element. And so the basic idea of this is we're just going to have the loop from 0 to n, and then we're going to have a second loop from I that's going to go, and it's going to start from I by itself as a group, and then go backwards so that we calculate all possible groups as the last group. And we're just going to add the value right before it, plus the value of the group, to get the value of DPI. So let's go look at the code for this question. So the first thing we're going to do is we're going to read in the input. So I'm going to have cows and DP, I'm going to read it in, and I'm going to set the value of DPI already to cows I. And so what I'm going to be able to do is I'm actually going to be able to start from I equals 1, since we already covered when I equals 0 here. So we're going to have our two loops here. We're going to have I equals 1, I less than n, k equals 0, k less than k. And so what we're going to do is we're going to have a range between j to I inclusive. And so from j to I is going to be the last group. And so in this last group, size k, what we're going to do is we're going to keep looping until either we've A, create a group of size k, or B, if the value or the index of I is less than k, in order to prevent an overflow, we're going to have if j less than 0, we're going to break. And this just means we're not going to go until the full extent if the size of I minus k is less than 0. And so if it is in fact a valid range, we're going to have a value called cur max. And so what this is because we're going from 0 to k, what we can actually do is we can create a maximum value for this current range. And since the value of the range is simply just the maximum value in the range times the number of elements, then the group size here is just going to be kermax times k plus 1. And so dpi is going to be the max of itself, and dpj minus 1 plus the size of this group times the value. And so at the very end, we're just going to output dpn minus 1. And that's the end of our program.